Okay, we're still working with improper integrals. This one goes from 0 to infinity, and we've got sine squared of alpha inside of the integrand. So first of all, you could always plug in 0, and you could plug in any number that you want, no matter how large, into this, because it's just sine squared. It just keeps going. So we don't have to worry that, there's any discontinuity that's serious here, upon which we can't integrate. So we're not going to have to split it. We're just going to have to realize that we have a property of sine squared, which is that it is equivalent to 1/2 1 minus cosine of 2 alpha. It's the halving thing. So we have 1/2 times 1 minus cosine of 2 alpha is equivalent to sine squared of alpha. From 0 to infinity, the alpha. But remember, we can't work with infinity directly. So we're going to replace that with t and let the limit of t approach infinity. So now we could plug in the upper. We're going to have to first actually integrate this, and then we could start plugging in the upper and the lower bound. So the way we integrate this is bring out the 1/2. This is going to become alpha. This is going to become negative sine over 2 alpha. So we have alpha and negative 2 sine 2 alpha. Negative 1/2. Because it's cosine, when you integrate that, it's a positive. We're subtracting a positive, and we're dividing by 2. Negatives, there you go. I just woke up, I'm sorry. Alpha negative sine 2a over 2. T is what we're going to plug in for the first bound. So if you're keeping track here, we have 2 bounds, and we have to plug in the upper bound and subtract the lower bound. We're taking the limit as t approaches infinity of that entire thing, so you can't forget this. This is the most important thing we're really doing here. And it's t that we're going to plug in. So we're only going to plug it into the upper bound. So we have 2 bounds. We have the upper bound minus the lower bound, which has 0 in it. The upper bound, we're letting t replace this. So this is t minus sine of 2t over 2. On the other side, we're subtracting when we have 0 minus sine of 2 times 0 over 2. So what do we get when we let the limit of t approach infinity for this entire thing? Here we just get infinity, because we have infinity minus whatever this goes to, which is just infinity. It doesn't even really matter if you're subtracting. Well, sometimes it matters, but in this case it doesn't, because what happens if you just keep changing numbers here? If you keep changing numbers here, you're just going to get fluctuating numbers. You could keep increasing sine, and sine is not really growing and growing and growing. It's just fluctuating. It's just changing and changing and changing and changing numbers, because remember, the graph of sine and the graph of sine of 2 times something is pretty much the same. So this is just infinity. because we let the limit as t approaches infinity for this. So we could already tell that this is going to diverge because we have infinity diverges because we have infinity there. And here it doesn't really matter what this little number is, because if you have infinity and you're subtracting some little number that we know we're going to get from here, then it diverges.